Good evening, students. Any doubt in the previous class portions? So yesterday we were discussing about Unit 1, Unit 2 and Unit 3 topics. Any doubt? So today's class going to be the doubt clarification. Go through the topics. If you have any doubt, ask me. Am I audible? Any doubt? The screen is visible. Any doubt in the previous class portions? The screen is visible. If no doubts means just we will revise from third unit, second unit and first unit. So if you take the third unit, we have part A and part B. So in part A, we have linked list and the types of linked list: singly linked list, doubly linked list, and circularly linked list, its implementation and application. And second part, stack and queue implementation. Yesterday itself we discussed. Once again, I am revising. So if you take a linked list, we are representing the linked list not like arrays. We are creating a node and user-defined data structure called node, and the node is used to represent each and every node in the linked list. A node is a structured type, or it may be class type, with the variables data and address to the next node. So if you take the pictorial representation of any node in a single linked list or double linked list, we'll take a node with two portions. First one is place to store the value, and memory location to store the address of the next node. So that because why we are using the address along with the data means here the memory will not be allocated continuous. So we need to maintain the next node data because it is in the list. If it is in list, more than one element will be there. So the first number, second number, third number, and how they are connected with each other means each node is maintaining the address of previous node. In case of doubly linked list, it's maintaining both the previous address and the next address. And in the linked list, we are using two special keywords called head node and tail node. The head node is the first node in single linked list, and the head node will not have any previous node, and the last node in the linked list is called tail node. It will not have any other node, so it will have the address as null. Am I audible? We saw how to initialize the node. If you take the doubly linked list,
Yes, ma'am.
yes,
Yes, ma'am. Yes, ma'am.
you take the doubly linked list. It's maintaining both the forward address as well as the reverse address. So the node is created in such a way that it's having three portions. First one is address to the two pointer variables, previous and next. The previous stores the previous node's address, and the next pointer stores the address of next node's address. And in the data field, we are storing the actual value. Because here we are maintaining both the forward as well as reverse address of the nodes. So here we can travel, that is visiting or displaying the nodes, accessing the nodes in forward direction as well as reverse direction. It's possible. And in doubly linked list, we are using two special nodes called head node and tail node. The head node and tail node are dummy nodes that will not carry any value. They are used to mention the starting and end of the linked list. The head node will have the address of first node. The tail node will have the address of last node. It indicates this is the beginning and end of the linked list. And here, while declaring the doubly linked list nodes, we are creating a structure called node with the data may be integer, character, or float type, depending upon what kind of value we are going to store. And we are using two pointer variables called next and previous. Next is storing the address of next node's address. Previous is storing the address of the previous. So if we want to perform the operations with the linked list, we need to create the node. Then we have to initialize the node. First, we'll declare the node and we'll initialize the node with the dummy values. Then the newly created node will take the value, and the node will be, if it is only one node, then it will be pointing the head node, and it will be in between the head node and tail node. If there are already few nodes, the newly created node may be added in the head position or in the tail position or in between. The same way, if you take the logic of circularly linked list, here it is a variant or advanced version of the singly linked list or doubly linked list, where the head tail node is pointing back to the head node, so it forms a circular structure. So it starts from head, again it can come back to head. After crossing tail, it will come back to the head again. And in all the nodes, we can perform the operations like adding of nodes, deleting of nodes, and adding the nodes in the beginning, in between, or at the end. And the same way, deleting the nodes in the beginning or at the end or in between. So in doubly linked list, say we are maintaining the two pointers, store previous and store next. It's used to store the address of previous node and the successor node, and the data field is used to store the data. And a node is created like this. And how we are representing means head node and tail node. Head and tail are dummy nodes, and it's having the nodes, actual nodes are carrying the values, and the nodes are carrying the previous address and the next address. Each node is maintaining the address of previous node as well as next node. So visiting the nodes in the forward direction and visiting come back in the reverse direction, both is possible. And how we are performing the addition and deletion of values into the linked list means, especially in a doubly linked list, pushing a node or adding a node into the doubly linked list is similar to pushing a value into the linked list, but extra work is required to handle the pointer to the previous node. what we are doing, we can add the nodes in three different positions of the linked list. It can be added in the beginning or in the in between or at the end. Suppose if there are three nodes in the link, already the three nodes in the given linked list, and if you want to add a new node in the beginning of the existing linked list, what we will do, we'll create a node with already there are three nodes 1, 2, 3, and it is in the some order, and we are creating a new node called with the value 6, and it's having the previous address and the successor address. The pointers are there. Now the newly created node is going to be added in the first position, that is after the head position. What we are doing, what are all the steps we are following means set the previous address of the new node pointing to the head position, and because we are going to add in the beginning, so the head is there. After the head, the node 6 to be added. So the head is having some address. That address head will point to the newly created node, and the previous address will point to the successor next node. Now we are taking the new node. That node is pointing to the previous head node, and the next address of the new node is pointing to the first. And head is given null. That null is pointing the first node. Previously head node is there, and it's not having any previous address, and the head node is pointing the first node. Now the previous address of first node is given to the next address of the newly created node, and the previous address of the new node is taking the value null. If the previous address is null means it is the head node now. The same way, we can add a new node in between the existing two nodes. So we are creating a new node with the value 6. Now we want to add the newly created node in between node 1 and node 2. So what we are doing, node 1's next address is given pointing uh, the newly created node, and the next address of the 6 is pointing to the second node. So this particular new node 6 is added in between node 1 and node 2. So the first node's next is pointing new node, and the new node's next is pointing 2. Now the new node is added in between 1 and the new node 6 is added in between 1 and 2. The same way we can add a new node at the end of the linked list. So the 6 is added after the third node. So the newly created node, the previous address is given to the existing third node's address, and it takes the next address of the newly created node takes the value null. When a node is carrying the next address as null, it means it is the tail node. The same way we can perform addition deletion in the beginning, in between, as well as at the end from using doubly linked list. So there exists an doubly linked list with the head, tail, and three nodes 1, 2, 3. Now we want to delete the first node from the doubly linked list. So we are targeting the first. The link between the first node and the head node is removed, and the head is now directly pointing the second node's previous address, and the previous address of the second node is pointing taking the value null. So this link and this link is removed. It is directly pointing the head node. Now the first node is isolated, so it is eliminated. The same way, deletion of the in between any inner node. What we are doing now, there are three nodes 1, 2, 3. Now we want to eliminate the node 2. Now we have to remove the link between first node and second node. So this link is disconnected, this link is disconnected. For that purpose, what we are doing, the first node's next address is directly pointing to third node previous address, and the third node's previous address is directly pointing to the first node. So the second node is isolated, so it is deleted. Now 1 and 3, 2 is eliminated. The same way in the doubly linked list, we can delete the last node. So now we are want to delete the third node from the W linked list. What we are doing, the third node is previous address is pointing the second node. This particular link is removed and this null value is assigned in the second node itself. Then this link is totally cut. The null is given to the second node next address. So this becomes the last node. When a node is carrying the null address in the next field, it means there is no more nodes. So as we already discussed, the complexity of a doubly linked list for addition, insertion operation, the time and space complexity. To add one node into the linked list, we need order of 1 minute. And if you want to add 5 nodes, we need order of 5. Time complexity, 5 seconds or 5 minutes. And the space complexity also, to add one node, we need additional one memory space, depending upon the data type, integer, character or float. The same way for deletion operation also, to delete an node from the existing linked list, the time complexity is 1 minute, and the space complexity also, that node is eliminated, one memory space will be reallocated. And if you take the addition, insertion, time complexity is order of 1, and deletion process also, time and space complexity both are order of 1. And if you take the application of doubly linked list, it is used in various various computer science logics, like redo, undo process. So we are doing redo, undo, no, that operations, and forward and backward navigation, and it is used in navigation systems. And if you take the differences between singly linked list and doubly linked list, here here we are using only one pointer variable next address. Here we are using two pointer variables next and previous. And here it's maintaining only one forward address. So we can travel or traversal visit only in the forward direction. But here we are maintaining forward address as well as reverse address. So visiting all the nodes in the forward direction from head to tail and tail to head both is possible. And because we are maintaining only one address, so it occupies less memory space. But here we are maintaining two forward address, reverse address as well as data field. So we need to allocate the extra memory space for all the for previous address, next address as well as the data field. The single linked list can be represented using stacks, and the same way it can be, but doubly linked list we can go for stack or heap or binary tree structure. So any doubt with the linked list, single linked list, doubly linked list? So if you take the application of third unit topics, like real-time applications of the various data structures like arrays. The arrays are used in 2D arrays, that is two-dimensional arrays are with the rows and column values. It is used in image processing, that is editing, cut, copy, paste, background removal, resolution change. So in mobiles also we are performing a lot of corrections, no effects. We can change an image from color to black and white to pop film. So we are applying a lot of effects. So all the image processing operations, the array concept is used. The Scodo and chessboard or 2D arrays, because it's having rows and columns, 9 rows and 9 columns in chessboard. 8 cross 8, 64 check boxes. In an online exam question paper numbering, the arrays are used. Book titles in library, we are maintaining the arrays concept. In online book library issue and renewal process, library softwares. In online ticket booking, railways flight booking, we are using arrays. Contacts in cell phone, we are storing the contacts. No? So the phone contact, memory, SIM contact. So the array concept is used. The same way, if you take the linked list, the linked list concept is used in linked list concept is used in music players, where we can because the first song, the next song, if there are 5 songs stored in an drive or in the CD or in a DVD, so they will have the, if you put the play the second song, it's having the link. We can go forward, go reverse. In YouTube also, while playing the songs, we are what is that? We are forwarding, reversing, tense. So the concept linked list is used in music players, escalators. So in airports and railway stations, we are using escalators. They can move in. They can make an coming up from down or down to up in one any way. And in social media, contact, content feeds. So while sharing the information in the Facebook or Twitter, Instagram, share with the news feed, and train coaches or examples for linked list. We can say it is example for doubly linked list. And Tinder uses the doubly linked list concept, left right stripes. And if you take the real-time applications of stacks, where we are performing push and pop operations, undo redo operation buttons used in the word processors as well as in the web browsers, wearing, removing bangles. So if you are wearing, the girls are wearing bangles, no? So if you are wearing 6 bangles, if you want to remove the last bangle, we have to remove the previous 5 bangles. Because it's circular in pattern. Simply we cannot remove the last bangle without removing the previous one. And pile of dinner plates, stacked chairs. If chairs are put together in a conference halls, we are placing the chairs one above the another one. So they are also the stack concept. If you remove last chair, then only we can take the previous one. And changing wearables on cold evening, first in comes out last. And browser history or visited websites. So there also the concept is used. So if you take the applications of queues, printer spool, printer queue, sending emails. So if you are sending 4 5 emails or bulk emails, it will take a little bit a fraction of seconds gap. It will deliver to one by one within a fraction of second differences. Car washes in queue, server while responding to the requests. There are 100 students accessing the server at a time. There will be a little bit fraction of difference in providing the service. And operating system uses queues for job and task scheduling. First come first, that is in operating system, there are some algorithms. Least frequently used scheduling, most frequently used, least used. So they will give some preference and they will store the files and other things according to some category. The same way the graphs are used in social media networking. React's virtual DOM is using graph structure. MS Excel is using graph structure. Flight networks are using. And tree structure also used in databases, domain name servers, DNS servers, file systems, and coding compressions. So converting the folder into zip folder and posting questions. So there will be some hierarchy. So the comments and other things. And sorting algorithms are used in order things by their value. So in Flipkart and Amazon and all, we can apply the filters based on the price, based on the discount, based on the brand, or based on the ratings. The sorting algorithms are used. Back-end databases, merge sort. So while updating the database, while creating the versions of the database, merge sort is used. Playing cards, that time the sorting is used. So we will, after getting the cards, we will arrange it in some order. And the sort is used. The function sort, we use insertion sort, hybrid, quick sort, heap sort. Fastest, quick sort is faster than all other sorting methods. So yeah, these are the some of the real-time applications of the various data structures. Any doubt? Any doubt so far?
No,
No,
ma'am.
ma'am.
So if you say take some sample questions, how the questions will be asked there. So we already discussed so many times how the questions will be framed in data structures. So you know very well, based on the topics, the questions will be framed. They may ask what is data structure, what are all the what are the applications of the data structures, and how it is used in various projects and programs. What applications do data structures have? Dynamic memory allocation, model sets, network modeling, and reasons. They may ask based on first unit, what is the difference between linear and non-linear data structure, and what is exactly stack, what is stack, and how it is represented, what are the stack operations we are performing, last in first out, and what operations can we do with the stack. So it is last in first out stack, and we will check whether the stack is full, top is pointing max minus 1. If top is null, means stack is underflow. Push and pop operations are performed. Before pushing, stack is full or not, we will check. Before popping, we will check whether the stack is empty or underflow. What is the difference between queue? What is the definition of queue in data structure? The list a few uses of queue in data structure. So the queue is used in various sharing of resources, printer, plotter, and other devices. Printers, we are using CPU sharing, we are using, especially the servers, and the centralized photo uploads, sharing the drives, asynchronous data transfer in the file and sockets, and while playing the music in MP3 and CD players. So the queue concept is used. If you take what is the definition of doubly linked list, to give some specific examples. So we know very well doubly linked list is having, yeah, each node is having previous and pre and next pointers and data field. And it's having two special nodes, header and tail nodes without any data. And what is bubble sort? What is the algorithm behind the bubble sort? So the logic behind bubble sort is given. What is the benefit of using mechanism behind selection sort? So as per your theory subject, you're supposed to study bubble sort, selection sort, insertion sort based on brute force approach. Definitely they will ask you one question from brute force approach. As per the third unit, brute force approach, three sorting methods, one searching method. Three sorting methods are bubble sort, selection sort, insertion sort, or binary, or linear search. Out of these four topics, definitely you will get one question because they belongs to the brute force approach. Four topics are there. So if they want to, they have to ask one question from the first half and from the four topics: bubble sort, insertion sort, and selection sort, and a linear search. And the second part, divide and conquer approach, quick sort, merge sort, and binary search. Out of quick sort, merge sort, and binary search, they need to ask second unit, two questions will be asked. The first unit, two questions, second unit, two questions, one question from third unit. So definitely they will ask two questions, one question from first half, second half in first unit, one question from first half and second half in second unit. And there are only three topics in each first half and second half. You will get one question from that particular. Out of three topics, definitely you will get one question. The question may be based on the pseudo code, based on the algorithm, or explain with complexity, like that. So the selection sort comes under brute force approach, and this bubble sort also comes under brute force approach. one question from brute force approach, one question from divide and conquer approach. So you should know what is the logic behind divide and conquer approach. The merge sort and quick sort comes under divide and conquer approach as well as binary search. So the logic we know very well. Quick sort is very quick and very efficient. Definitely they may ask question based on quick sort or binary search or merge sort. What is linked list? To implement the linked list using any particular language. And so any doubt how questions will be asked? So if you take so other interrelated questions, they may ask how the queue is different from stack, why the queue is called a linear data structure, and how we can represent a queue using a C code, and how we can represent a stack and queue using linked data structure. Why, if you are using C language to implement the heterogeneous linked list, what pointer type will be used? And what are the factors which determine the choice of data structure in for a particular program. So there are a number of data structures available, what we are studying in the subject, which data structure you will apply in your project. So how will choose, because if you go to a shop, there are a number of phones available in the shop. For your purpose, you will buy a mobile based on your need or based on your based on some configuration and specification, and for what purpose you are going to use that particular product, maybe laptop or mobile phone or anything. So the same way, when there are a number of data structures available for programming purpose, how we'll choose a particular data structure in your project means based on the size of the data, how much memory it will occupy. When we use the stack, we are using how much memory it will occupy, what is the complexity, runtime and space-time complexity. The same way, the time complexity of the particular data structure. If you are using some sorting and searching technique, how much, what is the complexity, what is the efficiency, whether it is constant or quadratic or exponential, and the size of the storage. So the time complexity, space complexity, speed, these are the parameters which determine we will choose the particular data structure. What is the minimum number of queues needed to implement a priority queue? One queue is used to. What are the data structures used to perform the recursion? So the recursive concept is very important. Instead of performing any task using, especially in divide and conquer technique, we are using recursive function calls. The function calls itself, within the function, if you are calling the same function, then like n factorial. If you want to find out the factorial of n, the formula is n into n minus 1 factorial. So the n minus 1 factorial, once again, we will call the fact of n minus 1. The same way in quick sort and merge sort, we are calling quick sort for n by 2, quick sort for n by 2, two times. In the merge sort also, we'll call for the first of and second of. So the recursive algorithm is different from iterative algorithm. So the recursive algorithm reduces your time, and the iterative algorithms, it will go 1 to n times. Say iterative means we will be using for loop. Recursive means we will be calling the function within the function. What are the methods available for storing the sequential files? Algorithms used. What is the difference between stack and queue? And efficient data structure is used in the internal storage system. Linear and non-linear data structure. What is asymptotic notation? The asymptotic notation in the first unit is very, very important topic. That is time and space complexity. And, three notations: big O, big omega, and big theta. Within that, best case, worst case, and average case. So this is important. What are the design methodology for algorithms? Design steps. The meeting will end in another 3 minutes. Again, all of you join back. How many? So like that, the questions will be framed. What is DQ? What is NQ? What is the space and time complexity? Applications of queues. The common operations we can perform with the stack queue and linked list is addition, deletion, retrieval, and traversal.
Ma'am, can you please upload this PPTs?
I will upload. What
Okay,
is the main
ma'am.
advantage of linked list? What is the stack? What is sequential search? And what is the logic used? First, you need to study all the topics in the syllabus. Then, for your understanding and differentiating the topics, you need to refer this. So, what are the different types of linked list? Uh, what are the two features that most affect the performance of queue? What is recursive algorithm? Okay, I will upload.
Excuse me, ma'am.
Yes.
What all topics will be for module 3 for midterm?
What is the? Tell me once again.
Ma'am, till where we have to study for module 3?
Module 2, complete module you have to study. Module 2, I have uploaded
Ma'am,
two.
module 3, module 3.
Ma'am, module 3.
Module 2, I uploaded one PPT that contains sorting, searching, all the topics. Module 2 is sorting and searching. I uploaded one PPT as well as I uploaded one PDF file
Ma'am, he is asking
containing.
about from till where we need to study in module number 3.
Your voice is not audible. Whatever questions you are raising, louder.
And he is asking for module 3.
Module 3, you need to study at least the first half. First half means linked list. Second half is stack and queue as per the syllabus. So definitely, I think if they are taking 2.5 units, but the first half 2 units complete. Third unit first half. Third unit first half is linked list. You take the third unit first half. Screen is visible. So your third unit is having part A, part B. Part A is all about linked list. So in the linked list, we are singly linked list, doubly linked list, circularly linked list. And the part B is stack and queue. Definitely they will ask you one question from this and one question from this. Okay, just now we discussed the third unit, all the topics. What is doubly linked list, how it is represented in a Word file. The same thing I put in PPT with different notations. So I have already uploaded this also in your Google Classroom. So what is doubly linked list and why it is more advantage? What are the special features of doubly linked list compared to singly linked list? It is more quick and because it's maintaining two address, forward as well as reverse. Addition and deletion is very fast. It's having two main addresses. So traversal in forward direction, reverse direction is easy. Yesterday also we were discussing about the same third unit. What is doubly linked list? Each node is having element, previous address, next address. This is the representation. Memory to store the element, previous pointer, next pointer. This is a node. So there is two dummy nodes, head node and tail node. So the meeting will end in 1 minute. You need to join back. How we are storing the values. Each node is maintaining forward address as well as reverse address. So what are the special features? Dummy node, head and tail are dummy nodes, data node. Head is having null previous, tail is having null next.
Ma'am, how many questions will be coming from module 3? Can you please clarify?